So, ladies and gentlemen, we are going to talk about more about proofs. Oh, and I do have old homework to hand back to you guys and girls. And this is a note page coming out. 4, 5. So, what were some things that I saw on the quiz that stuck out? One, you goofed up inverse or converse, inverse, and contrapositive. In order for a biconditional statement to work, everything has to be true. Okay? If you do a biconditional statement, you drop the if and then, and you stick in if and only if. So those are some of the places I saw errors. As far as the bonus question went, I was a little concerned that I saw there was two different parts to it. There was either the one that was all the angles or the one that was the segments. And I had people on the segment one. Not enough. One more. Pass that back, please. One that I saw that stuck out a little bit. A couple people made this error a few times. Was you said it was the segment addition postulate when it was the angles, or if it was the angles, you said it was the opposite of that. So if it was supposed to be the angles, you told me it was a segment addition. If it was the segments, you told me it was the angle addition. So pay attention. If it's a straight line, that's a segment. If it's an angle, it's an angle. So they say the exact same thing, but just be cautious on those. But that's about all we have there. Also coming out to everyone, let's see, this is 5th period. There should be multiple assignments that are in here, so these are coming back. Some of you stapled them all together, so you're all good there. But just make sure if you're that person who tosses everything, make sure that your grades are appropriate before you toss. It gets tough sometimes when someone says, "Oh, but I threw that all away." Double check your assignments, please. Make sure I have them in. If you don't want to keep them, that's your own prerogative. But if you do keep them, that's awesome as well. But please be cautious if you throw some away. And so this week we are going to do more proofs. Tomorrow we're going to start reviewing. We have extra practice to review on Wednesday. Then we'll do the Chapter 2 test on Thursday. And I think, judging by what we saw on this past quiz, bless you, we're only seeing one more section. I think you all are pretty solid with where we're going with this. Yes, you will see proofs on more of the geometric ones, similar to what our bonus question was, more on the quiz. But between today, tomorrow, and Wednesday, we will work on these quite a bit. Yeah?
Is the chapter 2 is that a quiz or a test?
This will be a test on Thursday.
And you said no geometric?
No, this one will have geometric proofs on it. Yeah. So this will have proofs similar to what we had. But I believe between today, tomorrow, and Wednesday, I think we're going to get a nice firm grasp on this. Okay? We feel okay? Can we go? Ready, set, let's have some fun. And we're recording, so no more cussing. Yeah, all right. All right, so chapter 2, section 5, angle relationship theorems. Develop understanding of 3 angle relationship theorems that apply to understanding proofs. So we used the word bisect before. That means we're cutting something into 2 equal parts. You can bisect a segment, cuts that segment into 2 equal parts. You can bisect an angle, cuts an angle into 2 separate parts. So now we're going to talk about something called trisecting. Okay? It means cut it into 3 different parts. All right, so what I just said. So if we were to say that angle ABC and angle RST were trisected, and we knew that angle 1 and angle 2 are the same. If these are trisected, you could say that this angle here and this angle here have to be the same. You can say that this angle here and this angle here have to be the same. And if they're trisected, that means that this angle, and this angle are the exact same as this, and this. And so if this angle 2 is 30, this would be 30, this would be 30, this would be 30, this would be 30, that would be 30. Woo! So, conclusion, angle 1 is congruent to angle 2. You could go through and say that any of the angles are congruent, okay, because we are trisecting an angle. Definition of trisector. So definition of trisecting. Okay, what can we say about this? We could say a number of things. We know that ABC and RST are both trisected. That means they're cut into 3 equal parts. I mean, what do you want to say about this? Do you want to go in here and say, hey, let's put a Roman numeral 2, a Roman numeral 3, a Roman numeral 4, and a Roman numeral 5? And we could say that angle 2, angle 3, angle 4, angle 5, angle 5, all congruent. Definition of trisecting an angle, not trig, trisect. Yep.
Right, so for angle 1 on the left, you have obviously have the 1. So why do you have it on the next angle to the right? Why do you have the 1 line?
The 1, the 2, the 3, the 1, the 2, the 3.
Yeah.
Just trying to say in order. Because they told us this, but then they tell us trisect. So there's so many things we can say about this. I could say that this angle and this angle are saying this end, this one, 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 whatever combination. So any of these angles here will all be congruent to any of these angles here. And then I could even go further to where I could say, what about these 2 angles and these 2 angles? They have to be the same because, one, we're doing the angle addition of congruent angles, things like that. Yes,
Can you just say that angle ABC is congruent to RST?
we could say that then as well. It's because of the definition of angle. Yeah, we could say that as well. Okay, but I'm just trying to show you all the things we could say about these angles if they're trisected. So trisect, cut into equal parts. Definition of trisector means that they are going to be congruent sized angles. And so I think by exploring, we'll see a little bit more. Given angle 1 is congruent to angle 2. Okay? Could I state this? Angle CEA is congruent to angle BED. Angle bed. What am I doing to those 2 angles? What's the big conclusion? How big is angle BEC? We don't know, but we know that it's the exact same size angle that I'm going to add to each of the angles that are already congruent. So angle BEC is not going to change if I add it to angle 1. So what do you think I could say? What's the reason? Yeah.
Angle addition postulate.
Angle addition postulate right there. Angle addition. Nice. And a few of you have already gotten into saying that. AAP. Yeah. Okay, so I know that angle 1 and 2 are the exact same size angle. Okay, I'm going to add a third angle. I'm going to add angle BEC to both. So then I can say that the, excuse me. So being this angle right here is going to be added to both. That's going to allow me to say that this angle here is equal to this angle here. So I already had 2 congruent angles. Now I'm going to add another angle. I don't know what size it is, but I'm going to add that other angle to both of them. So that's going to allow us to say that the larger angles are now congruent because of the angle addition. Or like some of you said, some people would have put segment addition, and this is an angle. So watch out on that. Can I move forward? You all okay? All right, so given segment, now it's talking to segment. Segment AB is congruent to segment CD. So what are we ignoring on this problem as far as this problem goes? I'm ignoring the angles. I don't need any of the angle stuff. I'm just looking at this segment. So now what can we say? Can we state that segment AC is congruent to segment BD? If so, why? Yeah.
Would it be segment, addition, postulate?
Yeah, segment, addition, postulate. Or, like some of you want us to put, Sept. Okay? Does that make sense? So again, sometimes we might be just looking at the segment itself. It might have more information to the photograph or the picture, but we're just looking at the segments.
So the reason is because you're adding BC to AD and CD.
Mhm.
That's why.
So I have two congruent segments, and I'm going to add the exact same thing to each one. That's B equal. Okay? Let's see who's paying attention real quick. Why could I say this then? There you go. Definition of congruence for this. And if I state this, what does that allow me to do later in the problem? It allows you to substitute, okay? Does that make sense? So don't get into the dirty math of saying, oh, congruent and equal are the same thing. Get into realizing the equivalence of stating something. If it says it's equal, then you can go ahead and substitute. Now, here is a question that I don't have the best answer for, but I'm going to put it in yellow. Does that mean the same thing? My opinion says yes. Okay? My opinion says yes, that AC, segment AC is equal to segment BD. Should be the same thing as saying AC, the letter AC and the letters BD. That should be the same. So if you make the jump from segment AC is congruent to segment BD, if you say that segment AC is equal to segment BD, how I have the yellow above it, I think you're appropriately stating that. Okay? How do we feel? Everyone happy? No one sad? Oh, look at this. This is starting to look like Star Trek stuff. What? You saying Star Wars?
You said Star Trek.
Did you guys see the last Star Trek movie?
Which one?
The very last one that came out.
No, I haven't.
Not a, dude, they incorporated Beastie Boys into it.
Beastie Boys.
Who are Beastie Boys? Get out.
Alright.
I'm just kidding. You got it. You just need to look up the song "Sabotage" by Beastie Boys. It's like, it's incorporated in the movie. My opinion, you could have some love story that I wouldn't want to watch, and I'd want to barf every time I saw it and kick a dog. But if you incorporate Beastie Boys, I'll say it's the best movie. I'm sorry, I don't like those mushy films. I like sci-fi and blowing up stuff and cars racing. I don't like.
Oh, look. This is my high school sweetheart. We haven't seen each other in 80 years.
Sorry, I'm off task. I'm sorry. I'm horrible. All right. So let's see a few things that we know. This tells me that AB is congruent to AC. So AB. So this whole length here. Let's do better. We're gonna do the crayon and we're gonna go green. So we're stating this. That and this are congruent to each other. Is that okay so far? They're congruent. We know they're equal to each other, so we could say that AB is equal to AC because of the definition of congruence, but I don't know if we have to go there. And then we also know what? AD and AE are congruent. So now we know this and this are congruent. Is it okay that I'm using a crayon?
No.
Yeah, baby. All right. Is there anything that we can conclude about this without writing anything down yet? Yeah. Yeah.
Would DC be congruent to EB?
I don't have enough information to say that. No. Yeah.
Could you say that BD is equal to CE?
Ooh, BD is equal to CE or congruent to CE. What do you think?
Nice.
Can I state this? Can I state right here is congruent to right here? Okay? And the reason why this one doesn't work is I don't know these angles down here. I don't know quite where they're intersecting. I like the thought, but that's a great idea. But unfortunately, we're looking at the segment right now. So then go ahead and state that segment BD is congruent to segment EC. Okay? Should I say equal versus congruent? I look at the problem. We were using congruent above, so let's use congruent below. Are you going to be wrong if you give me the equal? Not necessarily, but just be careful. I mean, the big thing is take a look at those signs and make that match that sign if needed. Okay? What's the reason that's taking place? Yeah?
Segment subtraction.
Segment subtraction. So segment subtraction postulate. Or SSP. SSP. All right? What do y'all think? I like my crayon up there, by the way. Does everyone feel okay with that? So if I have two segments that are equal length, and then two shorter versions of those segments are equal in length, if I take those away, then I can be able to say that the remainder of each segment has to be congruent. Make sense? I'm feeling pretty good about this so far. Are we on the back side yet? No. One more, right? All right. Oh, shoot. Angle 1 is supplementary to angle 2. What does that mean?
Oh, wow. They add to 180 degrees.
Yeah, if I add them together, it makes 180. And angle 3 is supplementary to angle 2, because that means I would add those together. Okay, so I think it's important, if we're going to go through the proof, angle 1 is supplementary to angle 2. And then the second one, angle 3 is supplementary to angle 2. And then that's why. Givens. And again, I know that some people will throw the givens together saying, yeah, it's the same thing. I think it's better if you keep it separate. Each little statement you want to say separate from each other. Yes, it is more writing, but it is what it is. So I do not have enough to go and prove angle 1 is congruent to angle 3 at this point. So I want to say something about supplementary. What does supplementary mean? Yeah.
Wait, I have a question.
Talk to me.
Can you do angle 1 is supplementary to angle... Oh, wait. No, never mind.
Yeah.
Could you say that angle 1 plus angle 2?
There you go. I like it. Angle 1 plus angle 2 is equal to 180. If I say that, what else can I say?
Angle 3 plus
And what's the reasoning for this? Definition of supplementary. I like it. Def of sup. Okay? No, I don't think we need 12. What can we do? Ooh, oh yeah. Yeah.
You can do angle 1 plus angle 2 equals angle 3 plus angle 2.
Why can we say that? Not quite.
Transitive?
It's transitive. Why is it transitive and not substitution in this case? Because there's three things. That's it. Got it. Got it. All right. So, because these two things are equal to this, I can go ahead and state that angle 1 plus angle 2 is equal to angle 3 plus angle 2, because this is a transitive property. You have three items taking place. And then what's the very last thing I can do algebraically to this problem? Not substitution, subtraction. What am I subtracting from both sides? Angle 2. So then I can say angle 1 is equal to angle 2. And I forget. Oh, we want to say congruence. So we went to equals equals. So I'm going to go 6. I can do subtraction. And then what's the last step?
Angle 3.
Huh?
Angle 3. Angle 1 is...
Oh, angle 3 right here. Sorry about that. That should be an angle 3. Sorry about that. What's the very last thing I can state now? Look what we have to prove.
Angle 1 is congruent to
There you go. Angle 1 is congruent to angle what? 3. Why? Definition of congruence. So definition of congruence puts it together and takes it apart. "14-point proof. Are you able to see a thought process that goes through?
Yeah.
Is there a sequence of events that takes place? Yeah. Do some people want to combine steps? Yeah, but unfortunately that might get you into trouble. Okay? Might get you into trouble. Are some people's a little bit out of order? Yes. Does that mean it's wrong? No. Anna, not here? Okay. Yeah.
So in general, do you just wanna, like right after you do the givens, do you wanna prove them? Or like show what they mean and then figure out a way to solve it? Or like-
I would say so. So sometimes, like right now, these are starting to flow in with each other. But at a certain point, it's going to start getting to, you have to make weird leaps just to see if it might work. A really weird leap you guys and girls will see in calculus and pre-calculus. Okay, and it's a beautiful class. It really is. So don't allow it to frighten you. But there are certain things that are little go-to tricks to make it work. And there are certain things like in trigonometry that you have to do. One of them actually has to do with, well, I could think of both in trig and calc, the multiplying both sides by a conjugate, which is, if you have x plus 2, the conjugate is x minus 2, it's a simple term algebraic. That's a go-to on a lot of times, especially in calculus. And it takes a real complex problem and all of a sudden makes it beautiful. Okay? And so it's just, how do you know when to go to it? It's a matter of just practicing it. So this is actually, we'll start getting to a thing where you'll start seeing, oh, I can start making these leaps because of these theorems. And that's what the thought process has taken place, which it's awesome. So you guys are doing great. Can I move on? Is anyone stuck here? Are we good? Oh, I love this stuff. This is fantastic, fantastic stuff. All right, so we proved another theorem. Does this pop? Oh, wait, I got to turn the speakers on because this makes noise. Oh, yeah. Here we go. No? No? This will work. Uh-oh. There we go. I knew there was a sound bite in there. We just proved another theorem. So, theorem 2.7. Supplements of the same angle or congruent angles are congruent. Okay? So, here's the nice thing about the proof. You could also do theorem 2.7 if you wanted to put that as your thought process. How are you going to remember that? The only way you're going to remember theorem 2.7 is you write on a note card. Theorem 2.7, one side. On the other side, you put supplements of the same angle or of congruent angles are congruent. And then perhaps you draw a picture of what it looks like, which we just proved. Okay? But again, some of you will say, flashcards don't really work for me. Hey, bless you. I'm telling you, flashcards from here on out are really a great idea. And just get yourself a pack of 3x5s, start putting them down, start rifling through them. The quicker you do that, the more you'll have go-tos for the problem. That's this. That's this. That's this. Okay? And it's good practice for future math classes. Okay? Can I move forward, or is anyone still copying this? Could we use the same reasoning for complements of angles? So, theorem 2.8, complements of the same angle or of congruent angles are congruent. So we just talked about supplements, that's 180. What are complements then? 90s. Okay, so it still works the same way. Now, if you don't remember theorem 2.8 or theorem 2.7 as that term, then you give the reason. Which way is right? Both. In the world of mathematics, it would be better if you actually wrote the entire reason, because theorem 2.8, as far as this textbook goes, might not be the same as theorem 2.8 of another textbook. Which you would have thought the math committee would have gotten together and invited me to a meeting and said, dude, theorem 2.8 is only one and only one. But they still didn't invite me to these meetings. You want to know why? I wasn't born yet. How we feel? Life good? Was it a good weekend? You had 3 days off. I mean, that's pretty cool. May I move? Yeah.
So you can use theorem 2.7 or 2.8.
You could write that as your reason. Yeah. I will generally not go and refer to 2.7 or theorem 2.8. I'll generally go to what the theorem states. Just because it becomes easier for those who aren't doing the note cards.
So could you just say like definition of supplementary?
Alright. Angle 5 is complementary to angle 6. So what does that mean? They are 90 degrees if I add them together. Angle 7 is complementary to angle 8. So if I add them together, I also get 90 degrees. And angle 6 is congruent to angle 8. We want to prove that angle 5 is congruent to angle 7. So let's start proving. I think we could say why? Givens. Okay. And then let's move down a smidge. Then I could say my third step is angle 6 is congruent to angle 8. That's also given. Fourth step, there's a couple ways I could do it. Fourth and fifth step could be the same thing, but I could think going all the way down to the sixth step. Where should we go first with this problem? Go ahead.
Angle 5 plus angle 6 is 90.
Okay, I like that. And you can also say that angle 7 plus angle 8 is 90. What's another place we can go? Some of you might have seen it. It has to go with the givens. Yeah.
I don't know if this would be skipping a step, but you could say angle 5 plus angle 6 is equal to angle 7 plus
You skip. We'll get to that with the transitive property. I agree. Yeah.
Would it be angle 5 is equal to angle 7?
We can't say that yet. That's what we're trying to prove. But it has to do with equal. I agree. Yeah. There you go. So, we saw this. So this might be the next thing to do. Why? What's the reason? Definition of congruence. And this is going to allow me to do what? What will this allow me to do if I do this? It'll allow me to substitute in where I need. Okay? Now, are you wrong if you do the angle 5 is complementary to angle 6, or plus angle 6 equals 90, angle 7 plus angle 8 equals 90 for steps 4 and 5, and then step 6 have angle 6 is equal to angle 8? You're totally correct. I have found that in my math endeavors, the immediates take care of right away. That way you don't forget it, because you don't want to get docked on that little tiny silly thing that it's like, well, you know what I mean. I don't. You can't substitute in unless it's equal. It can't be congruent. Okay? So then, whether you put this as step 6 or as 4 or 5 or whatever, and then obviously the next ones, and everyone's thinking is really doing well on this. So angle 5, angle 6, and angle 7 plus angle 8 is equal to 90. And what did I do with 5 and 6? Definition of what? Definition of complementary. Why would that happen? Because they told us that angle 5 is a complement to angle 6. That means if I add angle 5 and 6 together, I get 90. Angle 7 is complementary to angle 8, so we can say that angle 7 plus angle 8 equals 90. Definition of complementary. Okay? What's our go-to? It's transitive. So angle 5 plus angle 6 is equal to angle 7 plus angle 8. That's our transitive property. Last step. Oops. Angle 5 to 6, 7 to 8. We're trying to prove 5 is congruent to 7. Ooh, this is a tougher one. Yeah.
Could you change the 8 into 6?
Okay. Remember we said this? So we can pick either 6 goes in for 8 or 8 goes in for 6. Which is the way you want to go? I don't know. Let's go ahead and sub in right there. What did we just do? And it's not transitive. Substitution. Okay? So this was imperative that this took place in order for this to take place. So getting here, it's like, oh, well, now we're kind of stuck. Well, being we just did this allows us to do a substitution. Again, I could have plugged in for either angle 6 or angle 8. Okay, it's going to work out the same way. So we use substitution on this one. This is a great problem. Last step, subtraction. So now we can go ahead and say that angle 5 is equal to angle 7. Subtraction. And we're proving congruence or equal. Oh, congruence. One last step. One last step. What's the last step?
Angle 5 is congruent to angle 7.
There you go. Angle 5 is congruent to angle 7, and that is because of definition of congruence. And again, this goes backwards and forwards, and there's your proof. 20-point proof. Yeah. Yeah. Would that be on a test?
Well, like in total.
How many proofs total could be on a test? Well, like that one right there is a 20-point proof. I don't think we can prove it any less than that. So that would make your test, it would probably, so I always try to make your test worth about 100 points. Now, am I always right on? Sometimes it might be 97 points, sometimes it might be 106 points. I do that for a number of reasons. One, I have a sense of humor. That way, I'm sorry. And then it becomes harder. You know, if it's over 100%, you know, always know, oh, I got a 73, you're not 73%. But it's 73 out of 93, you're like, oh, calculator time. So I sometimes do for like that. All right. I would say 4 or 5 proofs could be. Some might be right away, 2, 3, 4 steps. Some might be, could be. Okay. Where does your mind go with it? I don't know. This is changes your whole outlook on math. But it's beautiful math. I love it. Can I move on?
Totally.
Yeah, baby. How would you classify angles 1 and 2 just by looking at them?
Supplementary.
Supplementary. What property do the two angles always have? Angle 1 plus angle 2 equals 180. Can we prove this? Probably. Okay. Does everyone feel okay? So there's a number of ways that we could represent angle 1 and angle 2. The problem might tell us that angle 1 and angle 2 are a linear pair. Linear pair means the two angles put together form a straight line. A straight line is 180 degrees. Okay, there's A lot of information we can put with this. We can just say that angle 1 and angle 2 are supplementary to each other, which also means that angle 1 plus angle 2 has to equal 180 degrees. If they tell you it's a linear pair, your next step could be angle 1 plus angle 2 equals 180. It's not definition of supplementary in this case. Why is that? It's a straight line. We called it a linear pair. So if they tell you angle 1 and angle 2 form a linear pair, and your next step is saying angle 1 plus angle 2 equals 180, you're totally correct. Be careful about your reasoning. Don't say definition of supplementary. They didn't tell you they were supplementary. They told you you were a linear pair, so use the verbiage they gave you. Okay? Yeah.
What property did the two angles in A always have?
1 and 2 are supplementary.
No, but the sentence.
What property do the two angles in I don't know. Oh. Stinks being a math teacher. Our grammar sucks. That's why X equals so many things these days. I don't know why they just ignore that sentence. It's poorly written. Doesn't make sense. Oh! What did I just talk about? Linear pairs. Let's see. Is there anything here? Oh yeah. The angles in a linear pair are supplementary. The angles in a linear pair are supplementary. Way. So if I say supplementary angles, I say linear pair. It basically means the same thing. Can I move? Woo, moving. Given angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 4. Prove angle 3 is congruent to angle 4. All right, let's prove this. Why? Givens? Feel okay? Let's prove angle 3 is congruent to angle 4. Okay. 1 plus 3 equals? I like it. There it is. So we can go ahead and say that angle 1 plus angle 3 equals 180. And we can say that angle 2 plus angle 4 equals 180. Why can we say that? Angle what? Definition of supplementary angles? Yes? No? Or supplementary? Either way, it'll be fine. At that, we could probably go ahead and state this. Why? Transitive, good. But now I'm stuck.
Why wouldn't it be substitution?
Because it's not, here's three things. This whole thing equals 180. This whole thing equals 180. I have 1, 2, 3 things. Yeah.
Could you say angle 1 and angle 2 are vertical angles?
Therefore, they're what?
The same.
They're the same. Ooh. What do you think? Angle 1 is congruent to angle 2. Definition, vertical angles. Angle 1 is congruent to angle 2. Definition of vertical angles. Nope, 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 nope. Okay, this might be able to make this leap without a problem. Which way is correct? I think you have an argument both ways. So we'll have that kind of put there as both. If you put angle 1 equals angle 2, that saves you the one last step. And then definition of vertical angles. Does anyone else wish they renamed it, didn't have it at vertical angles? That means straight up and down. So, being we were able to state this as well, what property can I use? Substitution. So then I can go ahead and state that I'll plug it in either here or here. So angle 1 or angle 2 doesn't matter. So I'll plug in right here. I'll plug in angle 2 plus angle 3 equals angle 2 plus angle 4. And what did I just do? Substitution. Step 8. Angle 3 equals angle 4. Why? Subtraction. And then were we trying to prove congruence? Angle 3 is congruent to angle 4. Why? Definition of congruence. Holy moly. This stuff was fun. This is fun. I love this stuff. This is my favorite stuff ever. All right, so ladies and gentlemen, our assignment for this evening, which I will mark off tomorrow, and here's the tough thing when you're doing these kinds of assignments. You sometimes get a little hung up, okay? Getting a little hung up where the whole thing's blank means you need a lot of extra help, and you better start coming in to see me. If you don't, it's really going to be, kind of a pain in the rear end. So it looks like worksheet 2.5. Worksheet 2.5 is a great way for you to show some of this. Okay? It's a couple proofs. First few are pretty quick, and then you get to 2-column proofs. Do I always give you enough room on the proofs? No. Okay? So, just be aware. How y'all feel? Are you guys happy with your quiz scores? I am so